We are going to discuss the phases of a compiler in the compiler design subject. In the previous video, I explained what a compiler is. A compiler is a program that translates source code written in a high-level programming language like C or Java into machine code, that is binary code that a computer can understand. The process of compilation happens in multiple phases. First one, lexical analysis. Second one, syntax analysis. Third one, semantic analysis. Intermediate, code generation, code optimization, and finally code generation. These are the 6 phases of compiler. Coming to the first phase of compiler, lexical analysis, it takes the source program and convert it into stream of tokens. So lexical analysis is also known as scanning, is the first phase of the compiler. Lexical analyzer or scanner reads the source program in the form of character stream and groups the logically related character together that are known as lexemes. For each lexeme, a token is generated by the lexical analyzer. A stream of token is generated as the output of the lexical analyzer phase, which act as an input for the syntax analysis phase. So lexical analyzer means scanner reads the source code character by character and convert it into tokens. So token is the smallest unit in the program or smallest element in the individual program, such as keyword, identifier, literals, operators, and keywords. In the lexical analysis phase, high-level language given as input to the lexical analysis phase, then it converted into stream of tokens. Coming to the example, in this program we are performing the addition operation. Within the main function, I initialized 3 variable and data type is integer. 10 value assigned to the variable A, 20 assigned to variable B. After that, we are performing the addition operation. Finally, it returns the result. In this program, how many tokens are there? So I already told you, token means keyword, identifier, literals, operators, and symbols. These are the tokens. Token means smallest element in the individual program. In this program, int is a keyword. Main identifier, open bracket and closed bracket symbols, and flower bracket symbol. Int keyword, a identifier, equal operator, 10 number, comma symbol. Next, b is an identifier, equal operator, 20 number, comma symbol, sum identifier, semicolon symbol. Next, sum identifier, equal operator, a identifier plus operator, b identifier, semicolon symbol, return keyword, sum identifier, semicolon symbol, and finally close bracket. So in this entire program, we have many tokens. So totally we are having 19 tokens in this program. Now second phase is syntax analysis. Here, stream of token is given as input to the syntax analyzer. Then the syntax analysis converted into parse tree and check whether the sequence of tokens follows the grammar rules of the programming language and builds a syntax tree or parse tree. So simply we can say that stream of tokens given as input to the syntax analyzer, then the syntax analysis converted into parse tree. Consider the example int sum equal to a plus b. Before constructing syntax tree or parse tree, you should know what syntax tree is. A syntax tree, also known as an abstract syntax tree, is a hierarchical tree representation of the structure of source code according to the grammar of a programming languages. How to draw a syntax tree? To draw a syntax tree, follow these steps. First one, identify the operator and operands, and second, determine the precedence and associativity, and last one, construct the tree. While we are constructing the tree, leaf nodes represent operands, constant, variable, identifier. Internal node represents operator. Root node represents the final computed values of the expression. In this expression, we are performing the addition operation. A plus B plus is an operator. A, B operand. Then evaluate A plus B, assign the result to sum. In this expression, we have two operators plus equal. Plus we are performing the addition operation. I mean we are evaluating and the result is assigned to that sum variable. How do we construct the tree? First A, B are operand and internal nodes going to be operator. We are evaluating a plus b, then assign the result to sum. This is the way we are constructing the abstract representation of syntax tree. We done this part lexical analysis, syntax analysis. The syntax analysis produced the parse tree given as input to the semantic analyzer. Then semantic analyzer semantically verified. Ensure the program has meaningful logic, and it check type compatibility, function calls, variable scope, and declaration rules. In this example, int sum equal to a plus b, both a and b are integer, it is valid code. Instead of a, if I substitute string hello, it cannot add a string and an integer 10. In the time you will get a semantic error. The functions of semantic analysis checks variable declaration before use, ensures correct data type in expression, verifies function return type and parameter matching. Here semantic analysis semantically verified whether the program has meaningful logic. Next, in intermediate code generation phase, the parse tree representation of source code is converted into low level or machine like intermediate representation. The intermediate code should be easy to generate and easy to translate into machine language. There are several forms for representing the intermediate code. Three-address code is the most popular form for representing intermediate code. It transforms the high-level source code into an intermediate representation, make it easier to optimize before generating machine code. For your simple understanding, intermediate code generation converts syntax tree into an intermediate representation. Three-address code is an intermediate representation used in compiler to simplify code optimization and translation into machine code. It breaks down complex expression into simple instruction with at most 3 operands. It uses temporary variable to store intermediate results. Coming to the example, sum equal to a plus b. This is the original C code. How do you represent the 3-address code? I told you, when you represent the 3-address code, the rule is at most 3 operand per instruction, uses temporary variable to store intermediate result, and simplify complex expression into multiple simple steps. Here, variable A is assigned to the temporary variable T1, B variable assigned to the temporary variable T2, compute T1 plus T2 and store it in a temporary variable T3, then store the T3 result in sum. This is the way we are generating the 3-address code. Next, code optimization phase. In the compiler that improves the intermediate code without changing its output. The goal is to enhance performance by reducing execution time, memory usage, or power consumption. Code optimization phase, which is an optional phase, perform the optimization of the intermediate code. Optimization means making the code shorter and less complex, so that it can be executed faster and it takes less space. The output of the code generation phase is also known as intermediate code, which perform the same task as the input but requires lesser time and space. In this code optimization example, before optimization, 10 value assigned to temporary variable 1, 20 assigned to T2. After that, evaluate T1 plus T2 and assign to T3. Finally, it returns T3. So in this code, after the optimization, you will get a return 30. Code optimization means you are going to reduce the code and it improves the performance by reducing execution time and memory usage. And the last one, code generation phase, it converts intermediate code into target machine code. It translates the intermediate code representation of the source program into target language program. If the target program is in machine language, the code generator produces the target code by assigning register or memory location to store variables defined in the program and to hold the intermediate computation result. The machine code produced by the code generation phase can be executed directly on machine. For your understanding, code generation means it converts the optimized intermediate code into assembly or machine code. Coming to the example, optimized intermediate code is converted into assembly code. Coming to step 1, move R1, 10. The move instruction loads the value 10 into register R1. Here register R1, R2 are like faster memory location in the CPU. Coming to the second step, move R2, 20. The move instruction loads the value 20 into register R2. Then add instruction adds the value in R1 and R2 and stores the result in R3. Since R1 value would be 10 and R2 value would be 20, then the sum 10 plus 20 equal to 30 is stored in R3. Step 4, move R0, R3. The move instruction copies the value from R3 to R0. Since R3 equal to 30, R0 will also have 30. Finally, step 5, RET return ends the program and return the result stored in R0. The final output of the program is 30. Finally, we got the target code or assembly code using the 6 phases of compiler. In these phases of compiler, first high level language given as input to the lexical analyzer, then the lexical analyzer convert a stream of tokens. After that stream of tokens given as input to the syntax analyzer, then the syntax analyzer converted into parse tree. Then parse tree given as input to the semantic analyzer. Semantic analyzer verified the parse tree. I mean semantically verified. Then we are generating the 3 address code using the intermediate code generation. After that, we are going to reduce the code using the code optimization. And finally, we are converted the target machine code using the code generation phases. Here, symbol table is a data structure that is used by the compiler to record and collect information about source program, construct like variable name and all of its attributes, which provide information about the storage space occupied by a variable, that is name, type and scope of a variable. A symbol table should be designed in an efficient way so that it permits the compiler to locate the record for each token name quickly and also rapid transfer of data from the records. Error handler is invoked whenever any fault occurs in the compilation process of source program. Both the symbol table and error handling mechanism are associated with all phases of compiler. I hope you all understand the phases of a compiler. If you have any doubts, feel free to leave a comment in the comment box. Don't forget to subscribe to my channel and press the bell icon to receive notifications for more videos. Thank you.